So we're here at MWC with Frode from Ericsson Antenna System. Good to see you, Frode.
Good to see you, Gabriel, again.
So one of the things I wanted to ask you about was how does the antenna system help handle all the big surge in uplink traffic we're seeing and anticipating, and then to go with that, this expectation we're going to have this surge of AI?
Yeah, so on the uplink piece, which is really important and been a very big discussion topic here at MWC, we see it's growing a lot, as you said, partly because of the users are changing their behavior, also partly because we see AI use cases using uplink. So the way that we are really solving this in the networks that comes from our fundamental belief in our design process. So by using digital twins, network simulators and algorithms, we are able to really tune our antenna patterns or, so to say, remove interference in the network. This is really a big contributor to deliver better uplink performance. Then, of course, the second piece of this is our world PIM performance. We have minus 156 dBc PIM performance. This is definitely an industry-leading performance. Combining these two together, we deliver more than 30% better uplink purely due to the antenna.
And so I definitely hear that from operators, that uplink is a big area of focus for them. Tell us a bit about how, once you deploy the antenna, how that would benchmark out in a real network.
So what we see, both in our live benchmarks as well as in our simulators, that irrespective of your radio configuration, whether you have a 44R or even a 48R, we are able to squeeze 30% more uplink throughput out of the antenna pattern itself. So purely the antenna pattern can contribute on top with 30% increase in throughput.
30% increase for the end user purely through antenna improved.
That's
wow.
correct, Gabriel.
Yeah, that is epic, I think. And also, I guess, so important because it's those users who are at the edge or in a difficult scenario who are going to benefit.
Yeah, really good question. But another really important fact is that we are very good in layering our beams. So think a little bit about this, Gabriel, that you have the low band and then you're stacking all the bands up until 2600 on top of each other. By doing this very precisely, we are able to drive more carrier aggregation in the cell. So what we are seeing in benchmarks, we are able to drive 21% higher usage of carrier aggregation compared to the industry.
Okay, good stuff. I want to take a little pivot now, just understand a bit, mission critical communications, a big focus for Ericsson generally.
Yep.
What's the antenna play here?
So yeah, in mission critical, we really are working on purpose-built antennas. So we see really two segments that is sticking out. The one is FRMCS, which is the railways basically upgrade from today's GSMR 2G to 5G. And this is then beamforming technology where we are introducing in the 1900 band that is dedicated to the railways in Europe. So this is a very important spot and something we have purpose-built an antenna for. Then, of course, it is all the underground, whether it is tunnel, road or rail tunnel coverage. We have this purpose-built tunnel coverage antenna that is really enabling not only, in this case, mission critical, but everything from 600 megahertz up to 4 gigahertz of band, so to specialized tunnel coverage. Then finally, the last segment that we're working on is PPDR networks, where we have a purpose-built antenna in the 700 megahertz with really good coverage to secure the police and the fire brigade has coverage in all these areas where they cannot get to commercial operators.
Yeah, all super useful work, Frode.
Thank you.
Just to close us out then, as you're traveling around your region, talking to your customers and prospects, what's your number one call to action?
So the call to action definitely is that we need to take antenna modernization seriously. The antennas out there is really aging. We have made a big leap forward when it comes to engineering and use of precise antenna patterns. We're seeing that we can take out so much more traffic, whether it's uplink, whether it's carrier aggregation, out of our antenna patterns now that has been engineered through use of simulation technology. And this is definitely going to help us to take the additional traffic that we see given the frequency band that we have.
Brilliant, thank you very much.
No, thank you.